3 of the review. Okay, and after we simplified and after we learned to plug things in, we learned to solve for x. And so some of our solving for x problems were things like, very simply, they looked in 7th grade or 6th grade like this. And this would be a one-step problem to solve for x. You would add -3 to both sides, and you would get x is equal to 7. Well, in algebra, they don't look that easy. So they usually look a little bit more crazy just to start off with. And you have to try to isolate your x. So I'm going to move all my x's to one side and all my variables to the other side. So I like my variables on the left. So I'm going to take this variable and I'm going to, I shouldn't have underlined him, he looks like a division. I'm going to take this variable and I'm going to add the opposite because that makes a 0 and now he's gone on this side. But if I do it to one side, I have to do it to the other. And so a -7x and a +3x is a -4x. Minus 11 equals -35. And all I did was write down the pieces that I still had left on the side. And I just kind of brought them down so that I could start isolating that variable. Now I moved all the x's to the left, so I need to move my numbers to the right. So this 11 is really a -11, and so I'm going to add the opposite, which is a +11, to both sides. And I get -4x is equal to, and this is a -35 and a +11, so I'm really subtracting. So 35 minus 11 is 24, but it's going to be negative because this one has the greater absolute value. So now I'm going to divide by -4, and a -4 divided by -4 makes a 1, so I'm left with an x, 1x, and -24 divided by -4 is a +6. So my answer is x equals 6. Now, sometimes they ask you to check. Sometimes they don't. But I don't care whether they ask you to or not. You always earn bonus brownie points with me if you check your answers, because in math, there's no reason to get your problem wrong. If you can check it and you can plug it back in to make sure, you should, because then you'll know if you got it right or not. And then you can always do something to change it if you didn't get it right. So if I plug in my 6 that I got to my problem, I end up with, and it's like these are two sides. We want to keep them separate to see if they work out and balance each other. So 3 times 6 is 18 minus 11. Well, 18 minus 11 is 7. So this side needs to be 7 in order for these guys to be equal, which proves that my x really is 6. So 7 times 6 is 42 minus 35. And 42 minus 35, I have to borrow, and I get 12 minus 5, which is 7. And check, I did it right, so my answer of x equals 6 is the correct answer. Okay? Now, after we learned to solve for x and we practiced that a little bit, they changed it on you, and they said, okay, x isn't equal anymore, we're going to do some inequalities. And they gave you problems where you had to combine like terms and simplify, but you also had to graph and use the inequality symbol. Okay, so I need to solve this problem. I'm going to use some GEMDAS, I'm going to use some simplification, and then I'm going to solve for x. So first I'm going to do my grouping symbols. So I write everything else, and 3 minus 7 is a -4. And now I'm going to multiply because that's the first thing that I have to do. Still simplifying. 2 times -4 is a -8. And now to get my x alone, I have to move my 8. So I'm going to add 8 to both sides. And I'm left with a 3x on the left. Keep my grouping symbol, keep my inequality symbol. And 24 minus 8 is actually 16, but it's negative because this guy is the bigger one. There's more of him. And now I have to divide by 3. And I get x is greater than or equal to, 3 goes into 16 5 times with a 1 remainder. So my answer is x is greater than or equal to -5 1/3. So of course I had to graph it. And remember, you need 3 points on your graph. So I'm going to put a -6, a -5, and I'm going to put a 0 because I like 0. And so negative 5 1/3 would be somewhere right around here if I broke this into thirds. So I'm going to say, all right, my negative 5 1/3 is here. And x is greater. So I'm going to say, all right, well, let's plug in 6. If I plugged in that negative 6, is negative 6 greater than or equal to negative 5 1/3? And the answer is no. It's incorrect. So now I'm going to choose my 0 and say, all right, if I test 0, is 0 greater than or equal to negative 5 1/3? Yes, it is. So I shade in this direction. So there were a few things that we had to remember. We solved for x, just like we do with an equal sign. However, so the first thing you have to remember is solve for x like normal. But an equal to, a greater than an equal to, or a less than an equal to gives you a solid dot on your graph. A less than or a greater than gives you an open dot on your graph. Then you always have to shade. You have to shade in one direction or the other, meaning draw those arrows and show which way this is true, because there's not one answer for this. There are unlimited answers. All of these numbers on the number line, all the way up to positive infinity, are answers to this problem. So you have to show that with your shading. Okay? And then the other trick that they threw into us was if you multiply or divide by a negative number, you have to switch your inequality sign. So I'm going to show it to you in simplistic form. Okay? And so to solve for x, we're going to add the opposite to get our x's on one side and our numbers on the other. And we get negative 2x is less than or equal to 14. And now to get my x alone, I have to divide by that negative 2. And now I've just divided by a negative on both sides of my inequality sign. And so I have to change the inequality. Oh, Garrett's catching me. He's going to go chart it on the 8th grade board for you all. I added this wrong. 10 plus a negative 4 is a negative 6. So Garrett marked you guys. Oh, positive 6. Okay. So now when I divide by a negative 2, I get x and I get a negative 3 here. But the key is taking this piece, and because I have done a division by a negative 2 on both sides of the inequality, I have to switch that sign. And so I switch it to x is greater than or equal to negative 3. And of course, then there's the graphing component. And remember, you have to put at least 3 numbers on your number line, and we have to check which way are we going to graph. If I plug in a negative 4 here, is negative 4 greater than or equal to negative 3? No, it is not. It is smaller. If I plug in my 0, so that means this one didn't work. If I plug in this guy, is 0 greater than or equal to negative 3? Yes, it is. So that's the direction I want to shade. Okay, and put my arrow. Now, do I need an open dot or a closed dot? Garrett, what do you think?
Closed.
Garrett says a closed dot. Why?
Because it's a greater than or equal to, not just greater than.
That's it. Because it has an equal to, it has to be a closed dot. And then you should always check your answers. And some of the problems say you have to, and some of them don't. So remember that when you're checking your answers, you start with your original problem, but you never plug in this answer. It's okay when it's an equal to, but it throws you off when it's a greater than or a less than. So I never check this answer. I always check the one that I did for my check for my shading. And so I use this 0 for the check for my shading, so that's what I'm going to check and make sure that it actually works. And so negative 2 times 0 is 0. So I'm left with a 4 is less than 10. Is that true? Yeah. So that means I shaded in the right direction and I solved my problem correctly. Okay? Now, it got harder because they introduced absolute values to us. And when they introduced absolute values to us, they started off really simple. They started off with equal to, with equations. And then they went to the inequalities. So the first thing that we have to remember is that when we're dealing with the absolute values, we always have 2 answers. Because what's inside of this absolute value symbol can either be a 5 or a negative 5. In order for it to come out of the absolute value and be equal to this 5 right here, I could have a 5 on the inside here, or I could have a negative 5. So you have to take what's on the absolute value and you have to set it equal to both of your choices. The positive 5 and then that negative 5. And now you solve for x. So I'm going to add a negative 4 to both sides, and I get x is equal to 1. That's one answer. And now I'm going to add negative 4 to both sides, and I get x is equal to negative 9. That's the second answer. And I should always plug them back in to check. If I have a negative 9, is negative 9 plus 4 equal to 5? Well, let's try it. Absolute value of negative 9 plus 4 equals 5. Negative 9 plus 4 is a negative 5. Is the absolute value of negative 5 is 5. So 5 does equal 5. So this one works. So now we have the absolute value of x plus 4, and we're going to plug in the 1. 1 plus 4 is the absolute value of 5, and the absolute value of 5 is 5. So 5 does equal 5, and so we checked it. It works. So you have to remember that you need two answers for your absolute values. But of course, they didn't say this super easy, right? They gave us inequalities, and then they gave us stuff on the outsides of them. So for the outsides, they did things like this. And we had to solve first to get our absolute value symbol alone. So the first thing I'm going to do is I'm going to add a 4 to both sides. And I'm left with 2 times the absolute value of x plus 4 is equal to 24. And now I have to get rid of my 2. So I divide both sides by 2. And I'm left with the absolute value of x plus 4 is equal to 12. And I want to see this. Remember, this is the piece that I always tell you, you guys leave off. I want to see it. Box it if you want to show it to me and make it super clear. And then you may take what's on the inside and you may set it equal to the number and to its opposite. So now I'm going to take it and I'm going to say I have x plus 4 is equal to 12, and I have x plus negative 4 and it's equal to, x plus 4 and it's equal to negative 12. Now I'm going to solve for my x. And I get x is equal to 8. That's one answer. And I get x is equal to negative 16. So I have my two answers. My two answers are that x can be 8 or x can be a negative 16. And you probably should have written the negative 16 first because we go lowest to highest. Okay, but there are two answers.
Least to greatest.
Least to greatest.